Hello, and welcome to another deep dive on this explainer. If you are a focused, driven learner looking to completely bulletproof your Cambridge physics exam strategy, you are in exactly the right place. Today, we are taking on a micro topic that routinely, and I mean literally every single year, trips up countless students: friction. But listen closely, because we aren't just going to sit here and memorize textbook definitions. We are going to build a clear, pitfall-free exam strategy to master exactly how friction appears in real systems, in tricky calculations, and in those really intimidating structured exam questions. Whether you are tackling the classic 0625 syllabus, the combined and coordinated sciences like 0651 and 0652, the 5054 O-level, or even laying the groundwork for the advanced 9702 A-level material, the principles we cover today are your absolute bedrock. Before we jump in, let me introduce you to two types of students I see all the time. Let's call them Alex and Sam. Now, Alex is a hard worker. Alex overloads every exam answer with raw, unadulterated physics facts, just paragraphs of equations and definitions, but absolutely no analysis. On the other hand, we have Sam. Sam rushes. Sam reads a question, completely misses the specific command word requirements, and writes down the very first thing that comes to mind. In this explainer, we are going to look at the flawed answers from students exactly like Alex and Sam, and we're going to transform them. We're going to read the warning signs, avoid the common pitfalls that sink grades, and visualize exactly what examiners are desperately looking for.
To really kick things off today, before we even look at a single formula or draw a single free body diagram, I want you to sit back and consider this one question. Think about it for a second. What physical effect, measurement, or prediction actually depends on understanding friction? Starting your revision with this exact hook is a massive, absolute game changer. Asking this simple question first makes the physics feel completely necessary, rather than just feeling like decorative memorization for a test. It frames the entire topic not as some annoying hurdle you have to jump over for an examiner, but as a critical, fundamental key to unlocking how the entire physical world operates. When you realize that without friction, cars couldn't steer, buildings would slide off their foundations, and you literally couldn't even hold a pen to write your exam, the physics suddenly becomes real. It becomes tangible. And that is exactly the mindset you need to score in the top percentiles.
So here is our structured roadmap for today's session. First up, the friction hook. Second, the physics behind it. Third, we'll dive into real-life applications. Fourth, we'll look through the exam lens to spot those pesky pitfalls. And finally, we'll wrap up with a powerful 4-step memory prompt. Let's get right into it.
Section 1, the friction hook, and what we call application-first thinking.
Okay, we need to explore how we actually begin tackling a physics problem before our brains even try to scramble for equations. Notice the core concept right here, starting with concrete, everyday language. Remember our student Alex? When Alex sees a question about a block sliding down a ramp, Alex instantly panics and starts word-vomiting formulas onto the page. Mu equals F over R, kinetic energy equals half mv squared. But students constantly rush to throw complex physics vocabulary at a problem because they falsely believe that's what the examiner wants to see immediately. But actually, this application-first approach prevents you from relying purely on memorized wording. By starting with the concrete reality of a scenario, like imagining a car skidding on a wet, rainy road, or feeling the actual heat generated when you furiously rub your hands together on a cold day, you empower yourself to actually reason through entirely unfamiliar, weird exam questions. You build the fundamental logic first, and you attach the fancy vocabulary second. It is the exact difference between blindly reciting a textbook and actually thinking, breathing, and analyzing, like a true physicist. Before we continue and dive into the physics behind this, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Trust me, you want to be notified when we drop these strategies.
Moving right along to Section 2, the physics behind it. This is where we master cause and effect chaining.
Once we have that everyday, real-world foundation solidly in our minds, we need to transition into the absolute rigor expected by the Cambridge syllabus. Let's talk about our other student, Sam. Sam rushes and ignores the command words. When the exam says, explain the effect of friction, Sam just writes, friction slows things down. That is a classic, painful dropped mark. In physics, explaining friction requires linking a specific physical action directly to a measurable outcome. You cannot just list a bunch of isolated, disjointed facts and hope the examiner is generous enough to pick out the right ones. They won't. Whether the topic involves interpreting velocity time graphs, analyzing complex vector forces, looking at microscopic particle behavior, or tracking the motion of a falling object, you must rigorously focus on the why and the how of the physical changes happening. A truly strong explanation moves smoothly from everyday language straight into precise, undeniable physics vocabulary, showing exactly how one physical event directly triggers the next. For instance, instead of just vaguely saying friction causes heat, which is a middle school answer, you explain that kinetic energy is mechanically transferred to thermal energy due to the resistive forces between interacting moving surfaces. Do you hear the difference there? One is a guess, the other is a mathematical certainty. That is what actually secures the marks and pushes you across those grade boundaries.
To do that consistently without fail, we use a crucial 4-step scientific pattern. Let's walk through this physics success blueprint together. First, identify the specific quantity or phenomenon you are actually dealing with. Stop and ask, is this kinematics? Is this thermodynamics? Second, state the symbolic relationship or definition involved. This is where you bring in the formulas, but only when the physical setup is crystal clear in your mind. Third, explain the underlying physics. If you're looking at a graph, what does the slope physically represent? Is it acceleration? Is it resistance? And fourth, connect it right back to a real observation, an experiment, or mechanical device. Think about it. Whether you are dealing with the terminal velocity of a skydiver dropping through the atmosphere or calculating the safe braking distance of a heavy transport vehicle, top-tier Cambridge answers require both deep theoretical understanding and practical, real-world application. This exact 4-step sequence guarantees you hit both of those markers every single time you put pen to paper.
Welcome to Section 3, Real-Life Friction Applications. Let's talk about seeing physics in the wild.
Seeing physics in the wild is what takes these abstract, sometimes dry concepts out of the textbook and effectively glues them into your long-term memory. I want to do a quick mental workshop with you right now. Imagine a complex physics data table on your screen. You have 60 seconds to extract the core trend. What do you see? You see that friction isn't just one chapter, it's everywhere. This brilliantly illustrates just how wildly varied friction's applications actually are. Depending on the specific paper you're taking, friction could show up literally anywhere. It's in engineering and safety protocols, like the precise coefficient of friction needed for a ladder leaning against a wall. It's in the design of transport systems, like anti-lock braking mechanisms that prevent tires from skidding into kinetic friction. It dictates the efficiency of massive energy systems, where thermal loss must be mitigated by lubricants. It even pops up in the mechanics of medical technology and the vast scales of astronomy. Exam questions absolutely love to blend topics. They are famous for it. They might ask you about friction in the context of a space probe aggressively re-entering the Earth's atmosphere, where intense air resistance, which is just fluid friction, converts massive amounts of kinetic energy into blistering heat. Or they might ask you to calculate the thermal energy loss in a spinning electrical turbine. If you know these applications, nothing will surprise you.
Take a really good moment to digest this quote. A student should always be able to name at least one real situation where the concept matters and explain why the physics helps us predict or improve outcomes. Listen to me, this isn't just some nice, fluffy advice. It is a hardcore exam requirement. Having a go-to real-world example, like the specific water-channeling tread design on car tires for transport safety or the high-grade oil lubrication used in mechanical combustion engines, serves as an absolute anchor for your understanding. When you inevitably feel that wave of panic in an exam hall, this mental anchor pulls you right back to the physics reality. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Let's get back to the strategy.
Section 4, the exam lens. Let's expose those common pitfalls and learn how to avoid the grading traps.
Now, let's pivot and look directly through the eyes of the examiner to reveal exactly where students typically bleed marks. We're doing a find the flaw exercise right here. Notice the stark, glaring contrast on this slide. Let's bring back our friend Alex. The weak example on the left is Alex's specialty, and it's the most common way to completely sink your grade. A weak answer simply drops a mathematically correct formula onto the page, maybe writes F equals M or W equals FD, but completely fails to explain what the variables actually mean in the context of the question, or what physical effect is taking place. You have to understand, you do not get marks just from memorizing an equation from the syllabus. A calculator can do that. You get marks for proving you know how that equation governs reality. A strong answer, the kind that Sam is learning to write, clearly and deliberately links the physics process to an actual physical effect. It uses that strict cause and effect chain we discussed earlier, and it fully justifies the example provided with proper terminology. It's the difference between a C grade and an A star.
To make absolutely sure your answers always look like that top-tier strong example, I want to introduce you to a specialized framework. Now, you might have heard of the Peel framework and other writing-heavy subjects: point, evidence, explanation, link. Well, in physics, we use a highly targeted version of that to guarantee top marks. We call it the DREA method. Think of DREA as your absolute safest, most reliable framework for structuring extended exam answers. Let's do a speed writing visualization. Imagine a 30-second timer ticking down. How do you write a perfect paragraph? First, D, give the definition of the key idea or physical concept. Next, R, state the relationship. This is exactly where your equations, your mathematical proportions, or your formulas come in. Then, E, provide your explanation. This is the heavy lifting. Use a clear, undeniable cause and effect chain to explain how the variables interact. Finally, A, provide the application, showing a real-life example or linking it explicitly back to the specific scenario in the exam question. If you relentlessly follow the DREA method, you guarantee you are giving the examiner absolutely everything they need to award full marks. It acts as a structural guardrail. It completely stops you from writing long, rambling, contradictory paragraphs that waste your precious time and don't actually score you a single point. It forces you to be concise, accurate, and completely comprehensive.
Section 5. The 4-step memory prompt. This is how we bulletproof your revision for good.
All right, let's bring it all together into a final system. You have the strategy, you understand the command words, you have the DREA framework, but how do you permanently retain it? Let's establish a concrete, actionable tool, a cheat sheet recap, if you will, to lock this knowledge into your brain right before exam day. These 4 questions are your ultimate revision prompt. When reviewing friction, or frankly, absolutely any complex topic in the Cambridge syllabus, I want you to literally ask yourself these questions out loud. 1. What is the core idea? Keep it simple. 2. What actually changes physically in the system? Is energy transferred? Does velocity drop? 3. What specific mathematical quantity, equation, or graph demonstrates this change? And 4. Where is it practically used in the real world? If you can answer these 4 specific prompts aloud without glancing at your notes, your knowledge is absolutely secure. This covers the 3 golden rules that guarantee top marks: command word decoding, framework application, and time management. Because when you know exactly what to write, you don't waste time staring blankly at the page.
We have covered a massive amount of ground today, from application-first thinking to the structured brilliance of the DREA method. Students who actually implement these exact physics strategies see an average improvement of 2 full grade boundaries. But, and this is a big but, that only happens if they practice consistently with our weekly explainer videos. So I leave you with this provocative final thought. Knowing this clear, structured framework, how differently will you attack your very next Cambridge past paper question? Are you going to be an Alex, a Sam, or are you going to be an A-star strategist? Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. And before you go, drop a comment below with your target grade for physics and the biggest challenge you're facing right now. Our team actively reads and responds to every single comment. Like and share this video with a study partner who needs a boost. Ace the Exams. Your Cambridge success starts here. Thanks for joining me and happy studying.